Nonlinear systems. So a nonlinear system is basically where one of the equations or both is not linear. So we have a couple of examples up here. And so this first equation in the system is quadratic because of the x squared. The second one is actually linear, and we know that because it only has an exponent of a 1. So in this case, we have a quadratic and a line. You can also have a system of two quadratic equations as well. So let's talk about the number of solutions to a nonlinear system. So you can have no solution, and no solution means there's no intersection point. And the examples we have here are with a quadratic and a linear. Well, you can have no solution with two quadratics as well. So for example, it may look something like this, where these two quadratic functions will never intersect each other. Then you can have one solution where the two functions only cross in one place, x, y. And for a quadratic system with two quadratics, it may look like this, where it crosses only at the vertex. Or you can have a system with two solutions where there are two different intersection points for the two equations given. And for two quadratics, it may look something like this, where you've got two clear intersection points here and here. So before we start solving these, let's start writing these systems of equations for word problems. So the graph shows the height y in feet of a soccer ball x seconds after it is kicked from the base of a hill with an initial velocity of 30 feet per second. The linear function represents a hill with a constant slope. Write a system of equations that can model this situation. So what this is asking is to write an equation that represents this parabola and to write an equation that represents this linear function. So for the parabola, we use this model here, and this is the model for projectile motion, where we basically have gravity here and initial velocity, like a speed, and we have the initial height. And so in our word problem, we can find the initial velocity very quickly. It says that this ball was kicked with an initial velocity of 30 feet per second. So we know that v sub 0 is going to be equal to 30. The initial height we can either find from the word problem, so it says from the base of a hill, that's where it started, or we can think of it as a graph as the y-intercept. Well, the base of a hill means the bottom of a hill, so the height should be 0. And if we look at our graph to confirm, this quadratic has a y-intercept of 0. So to write this quadratic equation, we're going to substitute the values of v sub 0 and h sub 0. So we have y equals negative 16x squared plus v, which is the velocity, so 30x, plus the height, which is 0. Now, since it is a height of 0, we don't technically need to keep it into the problem, so we can simplify this down to negative 16x squared plus 30x for the quadratic function. Now, for the linear function, we have to remember back to algebra 1. So for a line, the easiest way to write is in y equals mx plus b. And so the b was the y-intercept, and the m was the slope. So the y-intercept is simple. It's right here at 0, 0. So we're going to have y equals something x plus 0. For the m, you can do this in quite a few ways. So you have the slope formula, so y2 minus y1 over x2 minus x1. And here's your two coordinates, x1 and y1, x2 and y2. Or you can use rise over run. We just need to be careful if we use rise over run because these grid lines do not always go by 1. In fact, this is not a rise of 1, it's a rise of 2. And that's because each of these grid lines is going up by 2 every time. So be careful if you're going to choose rise over run. If you choose to use your formula, you will make sure you do it correctly. So y2 is a 2, y1 is a 0, x2 is a 2, and x1 is a 0. And so if we simplify, we get 2 over 2, which is 1, which tracks with the rise and the run. So rise of 2 and then a run from here to here is 2. So you would still have 2 over 2. So the slope of your linear function is a 1. So our equation is y equals 1x plus 0, which we can simplify down just to being y equals x. So this is the system of equations that represents this situation. Pause the video, try the example underneath. And here's what you should have had for the second example. Now let's look at solving these nonlinear systems. And we're going to use substitution and elimination to solve. So the first two we're going to do using substitution, and the bottom two we're going to use elimination. So with substitution, the idea in the process itself isn't changing whether or not you have two linear functions or a quadratic and a linear or two quadratics. With substitution, we're trying to replace a variable with something else. And so in this case, we see that we have two sets of y's completely isolated. So we know that y is the same as negative 2x plus 3. So we're going to take negative 2x plus 3 and replace it in the top equation. So the first step is to replace. So negative 2x plus 3 is equal to x squared plus x minus 1. So the original y got replaced with what y was equal to on the bottom equation. Now you need to solve this guy for x. However, we see that we have an x squared, so we're not going to be able to solve this as simply as we did with two linear systems. So we're going to either use factoring, quadratic formula, or square roots in order to solve these equations. So in order to do any one of those methods, I need to move over all of my items, all of my terms to one side. So I'm going to move the 2x, so 3 equals x squared plus 3x minus 1. And then we need to move over the 3 as well. And you can do this in one step if you are able and comfortable doing this all in one step. And so now that we're here, we have to solve this quadratic equation. And in this case, we cannot use square roots because we have two different sets of x's. And so we're left with either factoring or the quadratic formula. So I'm going to try and attempt to use factoring. And so to use factoring, we need to do the a times c. So we need negative 4x squared, and I need to add up to be b, which is 3x. And so the two numbers that will do this is a negative 1 and a positive 4x. Negative 1x plus 4x makes the 3x that is needed in order to factor this efficiently. So let's break apart the value of b. So we have 0 equals x squared minus x plus 4x minus 4. And we continue with the factoring process. Find the common factor from the first two terms, which is an x. So pull the x to the side, and we have x minus 1 left over. The common factor from the back two, which is 4. So pull the 4 to the side, and we have x minus 1 left over. The x minus 1s are the same, so that's one factor. And the other factor is x plus 4. So now that we have factored it, we use the zero product property to split this into two linear equations. And now I can solve these individually for x. So for the first equation, we get 1 equals x, and that's one solution. And the second equation is negative 4 equals x, and that is the second solution. So normally, we would say that we were finished and we would move on to the next problem. However, in this case, we still need to find the value of y because we're dealing with a system of equations, not just a single quadratic. And so if we look at our original problem, it had not only x's, it also had y's as well. So once you find your values of x's, the last piece of this is you need to find the y's that match up with those individual x's. So we need to find the y value. And to do that, we're going to plug in the values of x that we found earlier. So the first one I'm going to substitute is x equals 1. And it doesn't matter which equation you substitute into, so pick the one that looks the simplest mathematically. And that would probably be the linear function. And so I'm going to use the linear function y equals negative 2x plus 3 to find the value of y. So y equals negative 2 times x is really a 1 plus 3. And if we simplify this down, negative 2 times 1 makes negative 2, and negative 2 plus 3 makes 1. So the first coordinate is an x value of 1 and a y value of 1. So this would be the first intersection point of my quadratic and my line. Now I need to find the second one. So I'm going to substitute x equals negative 4 into the same linear equation. Y equals negative 2 times negative 4 plus 3. And we end up with positive 8 plus 3, which makes 11. So my second solution is negative 4, 11. So your basic process, substitute into a variable, solve for whatever variable is left, whether it be x or y, take your solutions and substitute them back in to find the value of the other coordinate. So for number 2, let's look at number 2, and I will start you and you guys try to finish it yourself. We're going to use substitution because, again, I have two y's by themselves, so we're going to replace this here at the top. You could also use this and replace the bottom. It really doesn't matter which direction you choose to go. You're going to get the same answer either way. So negative x squared minus 2x plus 4 equals x squared minus 2x plus 4. So first thing we need to do is move everything to one side and then decide on using square roots, factoring, or the quadratic formula in order to find the values of x. Pause the video and try to find the values of x for this equation. And here's what you should have had for your solution. So when we move everything over, we realize that everything cancels out except for the x squared, which makes it very simple to solve with using square roots. We don't have to factor because there's only an x squared, not an x. And so we can use square roots to solve this down, and we get the square root of 0, which will be plus or minus 0. But a positive 0 and a negative 0 are really just 0. So there's really only one solution to this equation. Now that you have your x, you're going to use this and substitute it back into one of the original equations to find the value of y. So pause the video, find your value of y. And here's what you should have had for your solution. Plug in a 0 for either equation and you end up with a y value of 4. And so your coordinate for the solution is 0, 4. Now let's talk about elimination. So solving a system by elimination, normally with lines, you can decide whether you want to eliminate the x's or the y's with no problem on either. When you have a quadratic involved, though, we need to be careful because if you try to eliminate the x's, you need to make sure you eliminate the x squareds and the x's individually, which will not always be very simple to do. So if you choose elimination, the simplest way to go about this is actually eliminating the y. That way, all you have to get rid of is a single value of y and not having to worry about getting rid of the x squareds and the x's at the exact same time. So I'm going to put this guy into standard form. So I'm going to move things around. I need to get all the x's and y's together. So I'm going to add 5x here. I'm going to add 5x here. I'm going to add 5x on this side and add 5x on this side. So what this turns out to be is negative x squared plus 5x plus y equaling negative 7. And then we have 5x plus y equaling 9. So now if I want to eliminate the y's, I need to multiply something by a negative 1. Either the top or the bottom will be sufficient. I just chose the top equation to hopefully get rid of some of these extra negatives lying around. So negative 1 times negative x squared makes a positive x squared. Negative 1 times 5x makes negative 5x. Negative 1 times y makes negative y. And then negative 1 times negative 7 is a positive 7. On the bottom equation, we did not change it, so I'm going to rewrite it. 5x plus y equals 9. And now we can add these up and make sure the y values add to a 0. So there is no like term with x squared, so we're just going to drop it down. Negative 5x and 5x makes 0x, negative y plus y makes 0y, and then 9 plus 7 makes 16. And so we don't need these ones with the 0, so we just have x squared equals 16. So if we kind of look at what happened, we ended up actually getting rid of two things at once. We not only got rid of the y's, we also got rid of the x's. So sometimes you may end up with getting rid of more than what you planned on in the very beginning. So now let's continue solving. Since all we have is x squared, we can simply use square roots, and we get x equals positive or negative 4. But be careful, this is not one solution like the previous example. This is actually two solutions, 4 and negative 4. So we need to substitute both of these back in to find the y values that correspond to both of those x's. Now, it doesn't matter which one of these equations you substitute into, but again, choose the one that looks mathematically simpler, which in this case would probably be the linear function at the bottom. So that's the final piece of the puzzle. We need to find the y value. And so I'm going to substitute the first x equals 4. So we're going to have y equals negative 5 times 4 plus 9. Well, negative 5 times 4 is negative 20, and negative 20 plus 9 makes negative 11. So the first solution we have is 4 comma negative 11. Then we need to substitute in negative 4, and you're not going to end up with the same answer as before. So negative 5 times negative 4 plus 9 results in negative 5 times negative 4 is a positive 20. 20 plus 9 makes 29. So your other solution is negative 4 comma 29. So just because one's positive and one's negative doesn't mean you're going to end up with the same solution, just opposite signs. I'm going to help you start the last one, and then I want you to finish solving the last one on your own. So for example 4, we're going to use elimination again. This one doesn't need to be manipulated, and because they both are set up relatively the same way. We have y's on the left, and then x, and a constant on the right. So we can go ahead and start multiplying and trying to eliminate the y. So if I multiply this top equation by negative 1, we will hopefully be able to eliminate y. So we get negative y equals positive 3x squared plus 30x plus 76. And again, the bottom equation is going to stay the same, so I will rewrite it down at the bottom. And if we notice, trying to get rid of x's and x squareds may not have been simple on this one, which is why I chose to eliminate the y's instead. Because now this cancels out to be 0y, which we don't really need, but we'll fix it in a minute. And we're going to add all the other like terms together. 3x squared plus 2x makes 5x squared. 30 plus 20 is 50x, and 76 plus 44 is 120. So 0y is simply just 0. So we have 0 equals 5x squared plus 50x plus 120. And then before you start solving this, decide if you can maybe simplify the numbers a little bit. 5, 50, and 120 are all divisible by 5. So I'm going to divide 5 out of everything. So we have 0 equals x squared plus 10x plus 24. And now we need to solve this quadratic equation for x. And you can do that with either quadratic formula or factoring. And we cannot use square roots anymore because we have an x squared and an x separately. So square root will not work with this example. So pause the video, solve this for x using either the factoring method or the quadratic formula. And here's what you should have had for your two x's, negative 6 and negative 4. I chose to solve by factoring because I know that 6 times 4 makes 24 and also adds up to 10. Now we need to find the values of y. So take your x's, you're going to substitute them in either equation, top or bottom, doesn't, again, whichever one looks mathematically simpler to you, and determine the values of y's that correspond with each x. Pause the video and try to find the coordinates that are solutions to this system. And here were your two solutions for this example. Substitute negative 6 and you should end up with a y value of negative 4. Substitute negative 4 and you get another y value of negative 4. So these two coordinates have the same y value, yet different x's.